Now we're starting on a whole new area, which is sort of the nominal side of the economy. This is where prices, inflation, nominal interest rates, and so forth get determined. The first part of these slides is really all about price indices, and I'm going to go through them rather quickly. The second part of these slides is more about the theory of how the price level gets determined. Okay, so up until now, everything that we've done has been in the context of real models. So everything was in units of goods. And the prices that we had, the wage, the real interest rate, and so forth, were all relative prices. It was the price of one commodity in terms of another. Of course, in actual economies, prices are usually in dollars, they're nominal. And so what we're going to want to do is be able to translate the kinds of prices that we see in actual economies into the kinds of prices that matter for economic decisions. And those are the real prices. People's well-being depends on how much they can consume. And therefore depends on units of goods. And so what we're going to want to do then is convert dollar prices into goods and relative prices. And then we can ask questions like, how do prices compare across time? Well, to do that, what we want to do is create something called a price index. A price index tells us how much a market basket of goods costs over time, where this market basket basically reflects the purchases that a typical family would make. So the consumer price index is the most prominent example. And what the market basket does is it reflects the percentage of expenditures that the typical family makes on various kinds of commodities. And then it uses these expenditure shares as weight in constructing this index. Here's a simple example. Suppose you only buy two things, housing and then other stuff. You spend 40% of your expenditures on housing, 60% on other stuff. The price of housing today is PHT, and the price of other stuff is POT. Then the price index, which we just say is PT, is going to be 40% times the price of housing, 60% times the price of other stuff. And then what you do is you choose a base year, and in that base year, say you make this price index equal to 100. And then you can easily compare other years to the base year. So this is the CPI and the expenditure shares. What you see here is that the biggest expenditure is on housing, and it comes transportation followed by food and beverages. So this is I've sort of aggregated it up. Of course, in the actual CPI, there are thousands of goods and services. So I've just kind of aggregated these into major components. And you'll see that these weights will sum to 100%. And we'll say that in the base year, this index is equal to 100. Here we have used the base year as 1982. It's arbitrary what base year we choose. And then all the other CPIs are relative to that base year value. So what you can see here is that in general, you're going to see that prices are rising over time. Sometimes they rise a lot, sometimes they rise a little. Now let's use the notation of P subscript YYY, YYYY, as the price index in a certain year. And we can now look at some various uses of these price indices. So, for example, how much would a basket of goods that cost $1,103.46 in 1982 cost in 1983? And so what we want to do is we want to convert those 1982 dollars into 1983 dollars. To do that, we take the expenditures in 1982 multiply them by the ratio of the price index in 83 to 82, and that then gives us that in 1983, to buy that same basket of goods, you would have to spend $1,138.77. And then you can work backwards also. Suppose that this same basket in 2011 costs $1,103.46. Now you can ask, how much would it have cost in 1982 dollars? Well, now we're just going to take the $1,103.46 in 2011 dollars. We want to convert that into $82. So we multiply this $82 by this ratio, just following the same pattern that we had up above. But now what's unknown is this Y, the past dollars as opposed to future dollars. And we can just do the simple algebra, and what you see is that that basket would have cost in 1982 $473.39. So what is the idea here? The idea is that there was enough inflation between 82 and 2011 that the same set of goods and services cost almost 3 times as many dollars in 2011 as in 82. I'm going to skip through a lot of these. What we have here is a series of examples to show you how you can go back and forth converting dollars in one year to dollars in another year. And what you want to do is study these examples, make sure you understand where they're coming from. This is a practical example. Again, I'm not going to dwell on it, but here we're saying that, gee, gasoline cost $1.16 per gallon in 1990, and in 97 it cost $1.23 per gallon. So you want to ask, well, was it cheaper or more expensive in 97 than it was in 99? Obviously, it cost more dollars, but were those dollars able to buy more or fewer goods? And it turns out, if you go through the calculations, the gasoline was actually cheaper in 97 than it was in 99. Now we're going to take that price index and convert it into inflation rate. And so this should be familiar to you by now. We just find the annual inflation rate as 100 times the change in the log of the price level, which is giving us the percentage change in the price level, which is what the inflation rate is. And so then we can compute this series of inflation rates using that original price index. Once you have things in terms of inflation rates, well, inflation really is the growth rate of prices. So now we can use that rule of 70 formula to ask, how many years does it take for the price of something to double if, say, you have an inflation rate of 2%? What we're doing here is we're computing what the 23-year average inflation rate was from 82 to 2005. We find that the average inflation rate was a little bit over 3%. So if we use this rule of 70 and that 3% growth rate in the price level, what you see is it takes about 23 years for prices to double, if every year they're going up by 3.06%. Now what I'm doing is an example where we're taking wages, which are in dollars, and converting them into goods. So we're computing what the real wage is. Well, the real wage is just going to be the nominal wage divided by the price level. So we've written this stuff in terms of logs. So the real wage is little w, and this is just defined as big W over the price level. So if we take the log of little w, it just becomes the log of the difference between the nominal wage and the price level. And that's what we've done here. Okay, so what we're computing here is what is the growth rate or the percentage change in the real wage. But to continue with this example then, from 76 to 81, the average inflation rate was a bit over, it was almost 9%. From 96 to 2001, it was 2.5%. So then we can compute if the nominal wage growth from 76 to 81 was 6%, and from 96 to 2001 was 3%, what we can compute is that even though nominal wages grew by more in this early period, because inflation was so much higher, real wages actually fell by 2.75%. And in the later period, when inflation was much lower, nominal wage growth was also lower, but it was still implied a positive growth rate for real wages.